Today we will start with the chapter 2, that is evaluation of major programming language. In this chapter we will see that different programming languages, how they have evolved through time, what was the first programming languages looked like, and what are the current languages, and what is the connection between different programming languages. So this is a chart that actually explains the relationship between different programming languages in short. So it is difficult to see. I'm not sure whether you can see it in the screen, but let me try to zoom it. Wait. So this picture shows the relationship between different programming languages. So let me first point out some of the language that you know. So here, Java, okay, C Sharp, Python, okay, then C++, then C programming language. So this is the thread that we follow for academic education. So let me first explain this thread. Okay, what does this thread means? So first, let's ignore the rest of it. Let's start with C. So first, there is the C programming languages. What is the timeline? If you go back here in this direction, the timeline is around 1971, 72. Okay, so around that timeline. So we have the C programming language. Over the time, if you follow C, C has been divided, okay, or from the C programming languages, there have been two other programming languages. So if you directly come to here, okay, you see this, after C, we have C++, but it's not only from C alone. If you look here, there's another arrow that is coming from here. So there's one programming language that is called Simula 67. Okay, you see this name. So this programming language, or the concept or features of this programming language and C programming language, was combined together to create C++ programming language. And another timeline, if we follow here, that from the C programming language through the ANSI C, we have this Python. So Python programming language was actually created by the programming concept of C. And if you look here, there's another arrow here. So if I follow that arrow, okay, you see there's another programming language that is called Modula 8. So by combining this features of these two programming language, one is C and there is Modula 8. Okay, we have got Python. And now if I keep following this one, the C++. So after C++, we have from the C++, we have created Java, or we can say without any other language, just basic C++ evolved into Java, and another part of C++ evolved into C Sharp. Okay, and finally from the Java, it has evolved into two languages. So you see Java and C++ both were combined to create C Sharp. Okay, so if you learn Java, okay, or if you learn C++, okay, basically you will automatically have the most or the basic understanding of the C Sharp, because this programming language came from Java and C++. Okay, and then Java eventually have other versions, Java 5, Java 6, and so on. Okay, and the C Sharp has evolved into C Sharp 2, 3, 4 with different updates, added features, okay, libraries. But the basic idea, it came from Java and C++. Okay, and if you follow here, the Python programming languages that I have told you to learn for this course is actually coming from C and some features of Modula 8. So by combining these two programming languages, we got Python. And there are other languages, as you can see. If you look at the timeline, okay, you can also answer that when a certain programming language was created. For example, for Python, if you follow this timeline, it was around 1990, 1991. Okay, for Java, if you follow this timeline, it was around 1995. Okay, then for C Sharp, it was around 2000. So each programming languages was first developed in a lab at a certain amount of time. All of them have some advantages, but in the academic line, we actually follow this thread. We start with C programming language. Okay, before that, obviously there are other programming language. For example, before C programming language, it was called B programming language. Okay, and before that it was called BCPL. Okay, so these were the name of the programming languages before C. So BC, we can say that first, let me clear this up. So first we started with CPL. This is the programming language. Okay, we started with CPL. CPL changed to BCPL. From there, we called it B programming language, and finally it was called C programming language. And if you look closely, the B programming language was combined with Algol 68 to create C programming language. That means this programming language was, or the C programming language that we see currently, okay, it is the combination of B programming language and Algol 68. The word combination actually refers to different meaning. For some programming language, it means we have combined the features of two programming language. So what is a feature? So if I ask you that, hey, C++ actually came from C programming language and Simula 67. So what does this mean? That we took some of the concept or some of the features or some of the codes from C, and we also took some of the concept from Simula 67. Okay, and what are those concepts? Let's say we can say the object-oriented programming concept. Okay, so finally we have this Java programming language, Python, okay, then C Sharp. So in your course, in any of the academic course, actually, we actually follow this thread. We learn C, Python, Java, and we also go on this. So we actually learn only this part. Okay, we don't learn Ruby or Fortran and other programming languages. Okay, so I think that answers your question, that why instead of learning the other languages we only focus on C, C++, Java, because they all, and here is the PHP as well. Okay, PHP, look at PHP came from first C. Okay, C programming language started with C programming language. Then there's another programming language called small AWK. From there we have Perl programming language, and from the Perl we have PHP, JavaScript, and Ruby. So this one single programming language, or the concept of this Perl programming language, okay, we have created these three separate programming languages: PHP, JavaScript, and Ruby. Okay, and we also use some other programming languages in different development environment. We'll go to those later. But I hope this gives you the basic idea that why we actually learn certain programming languages, and why everyone says that if you learn one programming language, the rest of it will be easy as well. The answer is because all of them are connected. Okay, so if you learn C++, basically you know a part of C, you know a part of Java, you know part of Python and everything. If you learn Python, that means you have the concept of C, you have the concept of uh, ANSYS, and you have the concept of modulite. So this chart shows you that how the languages are connected. Okay, and if you look back, the languages that you use as a programmer right now or as a developer, I can say that you have used for web development, you have PHP; for Android development or desktop, we have Java; and for every other developments, like you can develop websites as well, you can develop for machine learning or for any other thing, you can use this Python as well. All of them, if you track them back, okay, so where all these languages evolve from, you see all these programming languages evolve from one single programming language, that is C. And that's why it's very important that you learn C programming language, at least to the basic understanding. Okay, so and some other places or some other sectors might use other languages, but if you learn this, okay, Python or Java or C Sharp, okay, so you can actually do the most of the works as you need to do as a fresher engineer or a developer. So anyway, let's go to the next slide. So what we will do in this course, sorry, in this chapter, okay, we will see that what are these programming languages are. So we have a little bit idea about Algol 68, Fortran, COBOL. So we'll have a little bit of idea that how these programming languages look like. Okay, so it's mostly theoretical, just to give you an idea that how these programming languages look like. Okay, so first we start with the first one, that is what is why we don't use machine code for a programming. So I think all of you know the answer to that already, that for example, if you want to add two operators in a machine code, the normal instructions, okay, that we have minimal hardware instruction is add this two registers and store that into the T8. That means add T0, T1 and store them to T8. But if you want to write the corresponding binary code, okay, you see this is the pattern, so you have to write 000 and so on. So obviously this is not easy to read. It has poor readability that we have studied in the last chapter. It has a poor modifiability. Like if I want to change from A equals to B plus 1 to A equals to C plus 2, there are a lot of things you have to change here. Okay, so this is also very difficult, right? Difficult to modify, and you don't know where to change. If you see this equation, that a equals to b plus 1, and if I ask you that instead of adding b, okay, add c, you know that I only need to change in this part, or I only need to change here. But if I ask you that this means a equals to b plus 1, make it a equals to b plus 2, do you know where to change? No, right? The answer is very difficult to find. And then that this type of coding, okay, was very tedious. That means it will take you long amount of time. You have made a lot of mistakes, okay. But for the machine, it was very easy, because machine could instantly understand this code. There's no translation needed, okay. But for the developers, it was actually a nightmare. So we needed some programming language so that we could actually develop programs faster, okay. And that's where the concept of MIPS came. So MIPS means microprocessor without interlocked pipeline stages. The idea is that we will use a certain number of instructions, okay, that will have like a keyword. So whenever we want to execute a program, or we want to write a set of programs, we will use this instruction set, okay, for to write the programs, which will be easier for us to remember. Now what they did, okay, so they first started with the shortcode. So for the instruction set, so instead of writing zeros and ones, okay, this is one of the first new languages, okay, we're calling it shortcodes, and it was developed by a scientist called John in 1949, okay. And it was developed for binary computers, okay, binary automatic computers. Now of this one used a small set of instruction. How? Look at this example. So instead of using binary values of plus, minus, or pause, or if else, okay, we used a set of instruction. So let me write it down here. I think it would be easier to understand. So let's say that I want to write a equals to b plus c. Let's say I want to write this, okay. So in the binary, I had to write a bunch of zeros and ones, okay. Let's say, let me give a dot here so you can understand. So I had to write a bunch of zeros and ones. But here, what you need to write first thing, so you have to write a. So what is the equal for what is the pair for equal? So if you look here, okay, you will see that equals to 0 3. That means instead of writing zeros and ones, you will write 0 3, because in here this instruction pair equals to equal means 0 3. So we have used a pair. Then let's say b, then let's say plus, okay. What is the instruction number for plus? 0 7. So you will write 0 7, and then you will write c. So if I again compare it, let's say a is converted to 0 0 1, then we have 0 3, b is converted to, let's say, 1 1 0, then we have 0 7, then let's 0 0 1. So you see, just by using this instruction pair, okay, of 0 3 0 7, it's now a little bit easy for me to understand that, okay, 0 3 means plus, 0 7 means 0 3 means equal, and 0 7 means plus. So in this way, okay, we had a huge number of instruction set, okay, that actually made our task more easier. For example, here is another example. I wanted to add two numbers, x naught, okay. So first is 0 0, no instruction starts, then x naught is a variable, okay. Let me clear this first. Where is it? Yeah, got it. So first we'll start with 0 0, that means our instructions or our program start. Then x naught is a variable or a register. Then we have 0 3, that means I want to write equal to. Then we have 20, number is for 20 is not given here, but it's a syntax. Then we have 0 6, 0 6 means we have absolute value, okay. And then finally we have y naught. So instead of writing this is the instruction that we want to write, that x naught equals to square root of absolute of y naught. So instead of writing this, now we can write this one, okay, using shortcode. And what is the advantage of writing this one? Because if you don't write this one, the other alternative is writing this one, like a bunch of zeros. Oh, sorry, that would be no two. So like huge streams of zeros and ones, zeros and ones, zeros and ones, which is very difficult to understand, modify, okay, and you might make a lot of mistakes, okay. So now you have two alternatives. Either you can start with the zeros and ones, or you can use this short code, and you have a set of dictionary which each of this code mean to write this syntax. So obviously I think everyone agree that we should go with this one. So this was the first programming languages in the binary computers. And what is the advantage? What is the advantage? Advantage was it was easy to now, little bit easier to read code, understand code, write code, modify code. But it was slow. It was 50 times slower than the machine code, because After you have written the code, it has to search for each of the corresponding signs, and then it has to translate them. Okay, so it was interpreted with a pure interpreter. In our last class we have seen the what is a pure interpreter, in case you forgot. So whenever you have a code, interpreter translates one line by line. So each of this line was translated. Okay, and it was very slow. So in short code, we use a set of instruction, okay, which made our life a little bit easier for the programmers. In 1949, we're talking about 1949, okay, note that. And but it was slower because we had to translate in the machine code. Now during the 1950s, okay, the problem was, if you remember, it was the first generation of computers. So the efficiency of the resources was very important, because then we had only a small number, 10 megabytes of RAM. Okay, we had a small amount of storage. The computers were huge. So making making the programmer's life easier was obviously was the goal. But whenever you say a computer is 50 times slower than the machine code, that's a huge difference, because then the processor was also very small, sorry, very small in terms of speed and the resources. So this was actually a major problem, because normally we don't bother that much, okay, because we can now code very fast. But whenever you're running the program, especially with the interpreter that translates only one line at a time, if the computer is 50 times slower, okay, that's a not an acceptable. So they actually started tried to develop, so what can be done about this. And to improve on that, they have uh, proposed another programming language that is called speed code. Okay, so what it did, it was again created, developed by John, okay, for IBM 701. Okay, and it was included the floating point operations, and it could handle branches, okay, auto increment registers, floating point operation. So there are some other features it had, but our main focus is here. So as you can understand from the name, it is speed code. That means they all tried to solve this problem that we had in the short code. Okay, so what they did, okay, they had their memory had only 700 usable words, okay, as the interpreter. So they have developed on the speed to the point that a simple add instruction took 4.2 millisecond to execute. That's good. But even though the problems that we had, okay, the Backus, the scientist, the John who created the program language, claimed that it took 2 weeks to program in a machine code would take only hours in a speed code. That means he's saying that if you need 2 weeks to write a program, okay, in machine code, it will only take you hours in the speed code. Okay, so the same program, let's say I have given you a project that do that project. In the machine code, it would take two weeks to write the project, but in the speed code, it will take you only hours. And it also has some features, but still the problem was there. Okay, so they actually tried to create how to solve the problem, and that's where the other languages comes in. We'll go to that, but before that, just one more time. So what is a compiler and the interpreter? So first of all, whenever you know that compiler translates the whole code at a time, but source code interpreter does it one line at a time. The source code means whenever you write the original code that you type in a compiler, that is we call the source code. What is the translation? Whenever you convert the source code into something a computer can read. Okay, for example, computer can read machine code. In that case, it's called translation. But if you translate the source code, let's say you have written a source code in Java, you have translated into C. That's not called translation. As long as the machine understands your code, okay, in that case it's only called translation. That means translating for the computer. Okay, don't get confused. Then what is a runtime? Runtime means when the program is executing the commands. Okay, that is after the compilation, it is called runtime. And what is a compiled program? That is a code that we translate just before the runtime. That means the program, the compiler have translated the code, but still the program is not running. And finally, we have already talked about the interpreted, that code translated on the fly during the execution. So one line translated, one line executed. So again, if you have any confusion, just try to remember this. Compiler translates the whole code. Okay, then if you have an error, it shows the error and then it starts executing. Interpreter start executing from the first line. Whenever there's an error, okay, it only stops there. So as you can see, we have different programming language classes. The first one is the procedural programming language, that is C, C++, C Sharp, Objective-C, Java, and Go. Then we have the scripting programming language, that is Python, PHP, Perl, Ruby. Then we have this functional programming language that you don't use that much. Okay. Then you have the compilation class. We can divide the programming into two parts. One is a static compilation, that is C, C++, C Sharp. Okay. You will learn more about the compilation and the compiler in your compiler course. Okay. And then there is a dynamic compilation class that are, we have Python, PHP, these are dynamic. Okay. And then depending on the type, we have two types of programming language. One is called weak programming language, that is C, C++, Objective-C. And there is Java, Python. These are strong programming languages depending on the type. And for the memory, we can divide any programming languages into two parts: managed, where we can manage the resources. Okay, there's a garbage collection and other processes, and some other languages where there is no process for memory management, like C, C++, Objective-C. So these three programming languages, they don't use any memory management, but other programming languages are actually use memory management. So there are different ways we can actually divide the programs, and we don't have to worry that much about the division, because our focus is not how the programs are divided, it's just to understand why they are divided. And to do that, I will just discuss about this, that why we divide the programming language into two parts: dynamic typing and static typing. So let me explain this, the division between these two. So look at this example, dynamically typed. What does this dynamically typed means? So whenever you want to write s equals to f double o variable and then n equals to s dot length, the dynamic type means it will automatically understand that the variables you have assigned is a string, and then it will start working on that. But in case of a statically typed, you have to specifically mention that the variable I'm trying to assign is a string. Okay, and then you have to say that this is also an integer. So one easier way to differentiate between dynamic and static is that in the dynamic, you don't have to mention small things like name of the variable, type of the variable. Okay, sorry, you have to mention the name, the type of the variable. Okay, the name, the data type. And in the static type, like, you have to mention everything, every small step. Okay, so what it does in the dynamically type, whenever you actually assign the variable, the compiler automatically detects that, okay, so this is a string, so that I will assign a string here. Okay, so compiler automatically creates s is a string because you have assigned a string there. So as the compiler detects and take the decision on its own, we call it dynamically typed programming language. And in this case, it's called statically typed because it's up to you to decide. So what is the advantage of dynamically typed? It's flexible. Okay, you don't have to waste time declaring the type of the variables and so on. Okay, it automatically detects and make decision, but it also leads to some unexpected runtime errors. Okay, and in case of statically typed, it's reliable, but it's sometimes you have to mention every small things, which becomes tedious, okay, and boring. Same way, we can say that static checks are before runtime, dynamic checks on the fly during the execution. Now, here is another example, programming language that we'll discuss. But let's first go to the quantum computing video.